Okay, so hello guys. This is the second part of the chapter 4 in the laboratory uh, class. Okay, so this is just a continuation of the acid-base equilibrium and solubility equilibrium. Okay, so tutuloy lang natin kung ano yung naiwan last time. Okay, so probably in the last week, okay, you were able to at least reach up to this topic. Okay, siguro naabot nyo hanggang acid-base equilibrium constant calculation. Okay, but before I even proceed with the next part, I'd like to refresh the questions na lang in the acid-base equilibrium. Okay, so instead of going directly to diprotic and triprotic acid, I will cover the acid-base equilibrium. Okay, so that we will be clear lalo. Okay. So again, this is quite a lengthy topic, but there will be chapters or may mga timestamps down this YouTube video. So please click on that portion na lang if you want to watch that part only. Okay. So because this will be a lengthy one. So let's proceed with the acid-base equilibrium calculation. Okay. So in doing acid-base equilibrium calculations, okay, this is just an application of your ice table, okay, and we can actually use this to get the ionization, the percent ionization, the concentration of the substances at equilibrium, or even the pH of the solution. Okay, so we use ice table to track all the changes in the concentration, and we use an unknown variable x to be the concentration that's missing, and then you just plug them into the equilibrium constant, then you get the value of x, diba? So ganun ginagawa natin. So let's just recall everything na so that in the following slides mas fresh na uli yung idea natin. Okay, so let me just show you one problem. So let's read this one. So calculate the equilibrium hydronium ion concentration. I will use this one na lang pala. Calculate the equilibrium hydronium ion concentration from 1.2 molar nitrous acid, okay, given the equilibrium equation and the Ka. Okay, so of course, first thing you have to do, you have to write an ice table, automatic yun. And then your equation has to be written on top of the ice table. You should only write those in aqueous or the gas phase, meaning this one that is liquid should not be written. So I'll write it as HNO2, okay, in equilibrium with H3O plus and NO2 minus, okay. So for the initial concentration, we'll just write whatever is stated. So in our problem, that's just 1.2 molar nitrous acid. Okay, sorry, I'll change my color because yung red medyo masakit sa eyes ko. So I'll just write 1.2 molar for the nitrous acid. And then for the H3O and NO2 minus, walang sinabi. So 0. So for the change, basically this is just the direction of the reaction. You can use the reaction quotient and compare it with the Ka to know the direction of the reaction. Pero ganito na lang, in as a shortcut, kung nasan yung 0, dun pupunta yung reaction. Okay? So for example, in this problem, we don't have any products at all. So 0 sila. So ibig sabihin, the reaction is going to the product side. So what does it mean in terms of change? So since the reaction is going to the product side, the amount of H3O and the NO2 minus will increase, okay? So meaning they will have a positive change. But for any HNO2, okay, kasi to the right yung reaction, so this will be the opposite naman. So it will be negative change. Okay, again, just to clarify, if you have a coefficient here, you have to include that there, okay? So kunwari may mga coefficient ka dyan, you have to include them, okay? Anyway, so that's how you write the change. Kung nasan yung 0, dun papunta yung reaction, okay? And for equilibrium, basically you're just going to combine the I and the C. Okay, so that will be 1.2 minus x. This will be x and another x. So these are called equilibrium expressions. So when we say expression, that means na you really don't know the concentration. Okay, wala tayong alam about the concentration, and may unknown variable x. So that's why it's called an expression. So, what we're going to do is to solve for the value of x. How? This expression needs to be written in your Ka expression or your equilibrium constant, and then we'll do some algebra to get the value of x. Okay? So, after doing the ice table, you need to write uh, the equilibrium constant. Okay, so that will be H3O plus NO2 minus and HNO2. Okay, ayan. So, mga equilibrium concentration yan. Okay, so H3O plus is just X, same as NO2. So, that will be X times X, right? So, lalagay ko na ng X square because you just need to multiply X with another X. So, that's just X square. And then for the HNO2, that's 1.2 minus X. Okay, and then we'll need to cross multiply, okay, and then rearrange the equation in this manner. So that will be ax squared plus bx plus c equals 0. Okay, so kasi magiging quadratic yan, right? So we have to do that. Okay, so let's cross multiply this there. Okay, by the way, I'm not going to write the Ka muna. Okay, so that mas madali yung ating calculation. Okay, and then I'll transpose everything to this side. Okay, so that will be 0 equals x squared minus Ka times 1.2 minus x. And then I can distribute the Ka na, no? So distribute. By the way, this topic requires quite some algebra technique, no? So I hope na okay lang kayo dyan. But if you're still having problem, just let your instructor know so that they can assist you further. Okay, so this is our expression wherein the Ka is 7.1 times 10 raised to negative 4. Okay, so plug in ko na siya. Kasi kapag sinulat ko to, medyo matagal eh. So yung Ka, ina-abbreviate ko muna until I end up with this expression. Okay, so 1.2 times the Ka, I don't know. So let's use the calculator. Yan. Okay. So 1.2 times 7.1 times 10 raised to negative 4. Okay, so that's 8.52 times 10 raised to negative 4. Okay, 8.52 times 10 raised to negative 4. Okay, and now you have this equation here. Why is it important that you have to arrange it from highest exponent to the lowest exponent, or actually no exponent at all? Okay, kasi this is a quadratic equation. So in order for us to get the value of x, we have to use quadratic equation. And as you know, in quadratic equation, you have the coefficients a, b, and c. Okay, so wherein a is the coefficient of x squared, b is the coefficient of x, and then c is just the constant. Okay, and they should be equated to 0. So ibig sabihin, that the coefficient of our x here, pag walang nakalagay, ibig sabihin 1 yun. So that is the value of a. Okay. And then for the b, this is 1. Okay. And then for the c, ito yun. By the way, if you have a negative sign, you have to include it. Okay? So, kailangan i-include siya. Okay? So, the value of A is 1. The value of B is 7.1 times 10 raised to negative 4. And the value of C is negative 8.52 times 10 raised to negative 4. And then what's next? You can use your quadratic equation. But I will not teach you the long method because, sayang oras. Let's use a calculator. Okay? By the way, not everyone is my student naman, no? Pero I think you have an idea that you can get a version of your Casio calculator by just using this keyword, no? So, paki-google na lang ito, ClassWiz Calc App. So, this is available in your App Store, okay? If you're using Apple, okay? So, yeah. If you're using Apple, you can just type this ClassWiz Calc App. It's free. I actually have one of this in my in my phone, and it's very convenient. In Android, meron din ganita. Okay? So you can go to Play Store and then sorry, not this one. Okay? Anyway, hanapin nyo na lang. Basta may ganito din doon. Okay. Okay. So I think ito dapat yung keyword. Meron yan eh. Okay. So anyway, I don't know. Okay. So basta kapag iPhone kayo, just type it. You can download it for free. Okay. Same with Android naman. Okay. So again, let's go back. So, instead of teaching you to do the long method of quadratic equation, sayang kasi oras natin doon, we'll just let our calculator do the work. Okay? So, how are we going to do that? Okay? So, we just need to enable the quadratic equation function of our calculator. So, we press mode and then press equation and then press ax squared plus bx plus c because this is a quadratic equation and we can see this thing. Okay, so in this thing, you have your a, your b, your c. Basically, whatever those values are, you have to plug them into those cells. Okay, so for a, that's 1 only. For b, that's 7.1 times 10 raised to negative 4. And then for c, that's negative 8.52 times 10 raised to negative 4. Again, if you have a negative sign, you have to include it. Okay, so make sure to double check your data. Okay, kasi baka mamaya may na-typo. Okay, so I think everything's okay naman. And then we can use the calculator so that it can return us the value of x. Okay, so according to algebra, whatever the highest degree is, that will tell you the number of x. Okay, kung ano yung highest degree, ganun karaming x mo. Okay, so this is the first root. Okay, so I'll just get 3 decimal places. Okay, so 0.029. Okay, so the first root is 0.029 molar. Okay, so that's concentration. And then the second root is 0.295. So in 3 decimal places, that's 0.30. Okay, but negative. Okay, negative 0.30. Okay, so now those are the two x values, and they will show up if you use this quadratic equation. Okay. Okay, so now we have two x values, but only one has to be used in our ice table. Ano yung gagamitin mo? If you are given two numbers in which one is positive, the other is negative, you always choose the positive root. Okay? So always positive yung root. Bakit? Kasi if you plug in the negative here, okay, pag plug in mo to, may negative bang concentration? Wala. It doesn't make sense. So meaning, yung positive lang yung kukunin natin. Okay, so we can just simply plug in everything. So that will be x1 Okay, so meaning the concentration of H3O will be 0.029 molar. For NO2 minus, that will be 0.029 molar as well. And then for the HNO2, that will be 1.2 minus 0.029, which is ilan? So 1.2 minus 0.029. Oopsie, sorry. By the way, if you want to get rid of this function, you just have to press Shift, clear, clear all, which is 3, and then press equal sign. So 1.2 minus 0.029. Okay, so 1.171. Kapag kinukuha naman yung pH, okay, so let's say you are asked to get the pH, ito yung gagamitin nyo na concentration. Okay? So that is if hanahanap yung pH. Okay? Let me just provide it na para alam niyo yung mga gagawin. Just get the negative log of that number. So it's 1.54. Okay, that is if kailangan yung pH. Now, okay, so there's actually a shortcut here, okay? And the shortcut is called the small x approximation. So, what does that mean? Okay, so first though is that in order for you to know whether you're going to apply the small x approximation, you have to know the ratio of the the ratio of the concentration by the equilibrium constant. If the ratio of the concentration and the equilibrium constant is greater than 1000, then you can use the shortcut. Okay? So, if hindi pwede yung shortcut, edi you have to do the quadratic equation. So, let's look at this problem. Can we apply the shortcut? Tignan natin. So, again, if you want to know if the shortcut will work, okay, will shortcut work? Ano daw gawin natin? So, you need to divide the concentration of your acid. I abbreviate the acid as HA and the Ka. Okay? So, divide natin sila. And let's see if that's greater than 1,000. So, we have 1.2 molar for the concentration. And then for the Ka, that's 7.1 times 10 raised to negative 4. So, 1.2 divided by 7.1 times 10 raised to negative 4. That's the quotient. So the quotient is 1,690. Okay. Okay, which exceeded what we want. Okay, di ba? Ang gusto lang natin is greater than 1,000. So meaning, sobra pa nga. Okay, so tama, no? The shortcut will work. Okay, so I'll write here small x approximation will work. Okay, so gagana yung small x approximation because the ratio of the concentration and the Ka is greater than 1,000. So now, what do we mean by the small x approximation? Did you know that there is something that causes the equation to be quadratic? Okay? May isang term dito na nagko-cause for your equation to be quadratic. And that is this one, the negative x term here. Kasi kung wala yung negative x, madali na lang sana yung life. So this is actually the root cause of your quadratic equation. That is the problem that the small x approximation wants to address. Okay? So sabi ng small x approximation is that if you have a ratio that's greater than 1,000, if you divide this concentration by the K, if that's greater than 1,000, then you can just simply omit this. Pwede mo siya burahin. Okay? And what will happen if you omit that? Okay? So let's do it. So I'll copy this one. Okay, so I'll write it here. So x squared is minus ka times 1.2 minus x. Okay? So suppose itong x na to mabubura kasi sabi natin the small x approximation will work. Ito at ito parate yung nabubura kapag small x. Ito yung target na. Okay, let me use a different ink color so that I can emphasize. So ito yung target ng small x. Okay, so yun yung target ng small x approximation. So if okay yung small x approximation, you just simply delete that. Okay? So we can just simply delete this, and what will happen? X squared minus ka 1 times 1.2. Okay, so lipat mo na lang uli dun sa kabila. So that's x squared equals ka 1.2 times ka. Okay, so to get the x, all you need to do is to just get the square root of the concentration times the ka. Okay, so ganun na lang pala. So instead of doing all these things, pwede naman pala i-ganun mo na lang. Kunan mo na lang yung square root ng concentration and the ka. I call this the square root of tsaka. Kung student ko kayo, alam niyo na siguro yung tsaka. Okay, if you use the small x approximation, you can just get the square root of tsaka. The CHA refers to the concentration, let's say, of an acid, and the Ka is just the equilibrium constant. Okay, so square root of tsaka. Okay, let's try to get the square root of 1.2 times the Ka. And I will this prove na yun nga rin makukuha nating x value. Okay, so let's get square root of 1.2 times the Ka, which is 7.1 times 10 raised to negative 4, 0.029 then. Ayun din nakuha natin, no? 0.029. Okay, so ganun lang. So that's how a small x approximation works. Okay, if you just see that the concentration divided by K is greater than 1000, then you don't really need to go this process. All you need to do is to just type the square root of the concentration of your acid times the K, or square root of tsaka, so that you can get the equilibrium value of x. That simple lang siya. Okay, so let's look at this problem. Can we apply the square root of tsaka here? I don't know. So let's read. Calculate the equilibrium hydronium ion concentration from 2 times 10 raised to negative 4 molar of that molecule. Okay, so C6H5NH3 plus with water producing C6H5NH2 plus hydronium ion. Okay, so again, let's write everything in our ice table. Okay, so that will be C6H5NH3 plus. Yung aqueous, wag mo na isulat. Okay, so that would be C6H5NH2 and your hydronium ion concentration. Now, let's look at the given. Ano sinabi? Okay, so the only given concentration is for the reactant. Okay, so that's 2 times 10 raised to negative 4 molar. But for the others, nothing was given. So, meaning 0 to 0 din yan. And just as I said, for the change, kung saan yung 0, dun yung change, positive change. Okay, so this will be positive x, another positive x, and then kung saan yung hindi 0, negative yung concentration change. And then for the equilibrium, all you have to do is to just combine the initial and the change. Na? So you just add them up. So this will be 2 times 10 raised to negative 4 minus x. This will be x and another x. So now, what we're going to do is to get the value of x by just simply plugging these equilibrium expressions into our k expression. So let me show you the k expression. So k is equal to the C6, H5, and H2 times the hydronium ion concentration divided by C6, H5, and H3 plus. Okay, and then let's plug in all the equilibrium concentrations. Okay, and including the Ka. Pero hindi ko muna isusulat yung Ka, ha? Okay. So for the numerator, this is x, and then this is another x. So that will just be x squared. Then for the denominator, I have 2 times 10 raised to negative 4 minus x. Before we proceed, let's check muna if pwede ba yung square root of Jaka. Can we use the small x approximation? So to know if the small x approximation will work, all we have to do is to divide this concentration with the Ka. If that's greater than 1000, then we can use the shortcut. But if that's not, then we have to do quadratic equation. Let's do that. So let's get the ratio of the concentration and the K value. If that's greater than 1000, then you can use the shortcut, but if not, then you have to do quadratic equation. So just type the concentration divided by the K value. Let's press equal sign. It's just 7. So the ratio is just 7.9. It's actually 8. So ibig sabihin, it's less than 1000. So we cannot use the shortcut. We have no choice. Okay. So long method tayo, wala tayong magagawa. Okay. Ilagay ko dito. Shortcut not allowed. Okay? So di pwede shortcut. So we have to do quadratic. Okay? So do quadratic. Okay, so I just simply transpose this term to the other side. So that gives me, Ka times 2 times 10 raised to negative 4 minus x. This one's x squared, and then I need to transpose this again to this side. By the way, if medyo mabilis, you can just simply pause the video. This is recorded naman in YouTube. No. And then we distribute the Ka value, okay? So let's distribute the Ka value. This is x squared, negative 2 times 10 is negative 4 Ka plus, x pala muna mauuna. Highest degree, then lowest degree. Okay, so this will be positive Kax minus 2 times 10 raised to negative 4 Ka. Oh, what's Ka? Well, that's given, no? So let's plug it in. Again, if you think I'm kind of quick, you can just pause the video. Okay? So ito, sa calcu ko na to itatype, ha? Okay. Anyway, so yan. So I am required to do quadratic equation because it doesn't fit the criteria for the shortcut. So again, the coefficient of x squared will be the a, the coefficient of x will be the b, and this thing here, including the negative sign, is the c. Okay? Let's use our calculator to get the roots. Again, press mode, equation, the ax squared plus bx plus c Then you type in the values of A, B, and C. Okay, so this is 1, 2.1 times 10 raised to negative 4, sorry, negative 5. And then this is negative 2 times 10 raised to negative 4 times 2.51 times 10 raised to negative 5. Okay, so I just type everything in the calcu. Ay, teka lang. I think may mali ako na type. So, 1, 2.5 times 10 raised to negative 5. Mali ako ng type dito. Let me just re-edit. Ayan. Okay, so it's negative 5.09 times 10 raised to negative 9. So I'll press the X twice. Okay, so this is the first X value. It's 5.94 times 10 raised to negative 5. Okay, so that's the molarity. And the second one is negative 8.45 times 10 raised to negative 5. Okay, so those are the two roots. So one is positive, the other is negative. So again, which of them will you choose? Of course, the negative. Okay? Sorry, yung positive pala. Yung negative, you just discard it because there's no negative concentration. So that means at equilibrium, the concentration of C6H5NH2 is 5.94 times 10 raised to negative 5. Same as this one. And then for the equilibrium of the C6H5NH3 plus, I'll just deduct the X1 from its initial concentration. So this will be X1, X1, X1. Okay, so let me just clear this again. 2 times 10 raised to negative 4 minus X1. 5.94 times 10 raised to negative 5. So 1.406 times 10 raised to negative 4. Okay, so those are the concentrations at equilibrium. Suppose you're asked to get the pH. So basically, the concentration of your hydronium ion will be used. Okay, just get the negative log of 5.94 times 10 raised to negative 5. So that's the answer, 4.23. So the pH is 4.23. Okay? So yan, so ganun lang. Let's try another problem. Right, sorry, I have a typo here. This is not actually Ka, rather it's Kb. Okay? So calculate the equilibrium hydroxide concentration from 0.075 molar of ammonia, wherein the reaction is shown, NH3 plus H2O in equilibrium with NH4 plus and OH minus. So again, just like what we did earlier, you just copy the aqueous, leaving the liquid untouched. Okay. Okay, so that's NH3, NH4 plus, and OH minus. For the initial concentration, so we are given the molarity of the ammonia only. But for the ammonium ion and the hydroxide ion, we are not given any info about it. So they are both 0. And whenever you have zeros, the direction of the reaction is going towards them. So that will be a positive change for ammonium ion, positive change for the hydroxide ion, and negative change for the ammonia. Okay, for the ammonia. Then we'll just combine the I and the C. Pagsamahin, so that will just be 0.075 minus x, so it'll be x and another x. And then what's next? Oh, you write the Kb. What's the Kb? That's the base equilibrium constant. Madali lang yan. Okay, so is this still the same naman? Okay, so that's our equation. All we need to do now is to include the equilibrium into the K expression. Yung Kb, mamaya ko na siya ita-type. Okay. So NH4 is X, OH is also X, so X times X is X squared. Then for the ammonia, okay, that's 0.075 minus X. Okay, pagdating dito, hold ka muna. Let's check whether we can use the shortcut. Can we use the shortcut? I don't know. So let's type the concentration divided by K. Okay, so the concentration is 0.075, and then the K value is 1.75 times 10 raised to negative 5. Is it greater than 1,000? Let's see. Okay, so it's greater than 1,000. Lucky for us, no? Because if it is greater than 1,000, then you can use the shortcut. Okay, so again, what do we do with the shortcut? So basically, this term here can be eliminated na. Okay, so we can eliminate that term na. Okay? Kasi siya yung dahilan ba't may quadratic tayo. Okay, so meaning, x squared is just your concentration times your Kb value. So x is just 0.075 Kb. And then, calculate na lang. So that's the square root of 0.075 times your Kb. 1.75 times 10 raised to negative 5. Ang bilis, no? You don't need to do quadratic anymore. So that will be 1.15. Okay, so let's round it up. 1.15 times 10 raised to negative 3. Okay, so 1.15 times 10 raised to negative 3. Okay, ayan na. Very easy. Kaya, just as I said to some of my students, no? Okay, not all of you are my students in the laboratory. Pero in my lab class, sabi ko sa kanila that if you can answer this very quickly, then kayang-kaya yung exams, okay? And then for this one, let's just subtract 0.075 minus 1.15 times 10 raised to negative 3. This is the remaining concentration. 0.074. So, yan na lang yung concentration niya. Okay. Bilis na. Basta marunong ka mag-identify if you can use shortcut or not. Okay, and now let's talk about percent ionization. When you say percent ionization, basically this is just the ratio of how much ions you have at equilibrium and the initial concentration. Okay? So, ratio to ng equilibrium concentration of ion and your initial concentration of the of your substance. If that is an acid, then that means you divide the concentration of H plus or hydronium ion with the initial concentration of acid times 100. So for strong acid, the percent ionization is obviously 100%, but for weak acids, the ionization is not that much. Okay, so again, there are many factors that results in uh, your substance being electrolyte or non-electrolyte. Let's try this one. Okay, so calculate the pH and the percent ionization of 0.5 molar acetic acid or CH3 CHOOH, whose K is 1.8 times 10 raised to negative 5. So, how will we answer this? You just write your ice table. Kasi what's the reaction, you might be thinking. So by now, you should know how to write the dissociation reaction. Kailangan marunong na. So all you need to do is to write CH3 COOH, and that will equilibrate with H plus and your anion. Okay? So ganun na lang gagawin nyo. Okay? And then we can plug in the concentration of our acetic acid. So that's 0.5 molar. And then for the others, walang sinabi. So 0 and then 0. Okay, for the change, kung nasan yung 0, dun positive. Okay, so this will be positive x. Positive x. And then this one will be negative x. And then I'll just need to combine everything. Once you combined everything, you can write them in our equilibrium constant K. So for that reaction, that's H plus CH3 COO minus divided by your acetic acid CH3 COOH. So let's plug in the values. I'm not going to write the K expression in its full form. Okay, for H3O plus, that's X. For CH3COO minus, that's also X. So X times X is X squared. And then for the CH3COOH, that's 0.5 minus X. No? What we're going to do is just cross multiply. Pero before you do that pala, shortcut. Tignan natin if the shortcut will work. Okay? Kasi baka mamaya nag-quadratic ka na, pwede naman pala mag-shortcut. So again, to do the shortcut, you just need to divide the concentration of your acid by its K. Okay, so let's do that. So concentration is 0.5. The Ka is 1.8 times 10 raised to negative 5. Let's see if the quotient is greater than 1,000. Okay, so greater than 1,000. So what does that imply? If the quotient of your concentration and your K value is greater than 1,000, then that means that you can just simply delete this X. Pwede mo na siya burahin. Okay? So katulad ng ginagawa natin kanina, so this will be X squared equals 0.5 times Ka. So to just get X, this is square root of 0.5 times the Ka. Yan pala yung X. It will just be 0.5 times the Ka. Okay? So the X value is 3 times 10 raised to negative 3. So 3 times 10 raised to negative 3. So yun yung X natin. Okay. So that's 0.5 minus the answer. 0.497. Yan yung bagong concentration ng acetic acid. For the hydronium ion, it's 3 times 10 is to negative 3. And for the acetate ion, so it's still the same, 3 times 10 raised to negative 3 molar. Okay, and now, how will we calculate the pH? So basically, you need to use this for the pH. Okay. So pH is the negative log of your H plus concentration. It's negative log of your H plus concentration. So that's 3 times 10 raised to negative 3. Okay, so the answer is 2.52. Okay, so probably the biggest question for your case is what's the percent ionization? So to get the percent ionization, we'll just use the equation earlier. So to get the percent ionization, all you have to do is to divide the concentration of your H plus and your original concentration times 100. So let's do that. Okay, so the equilibrium concentration of the acid is 3 times 10 raised to negative 3. And the initial concentration is just 0.5 times 100. Okay, so what's the percent ionization? Madali lang. So that's 3 times 10 raised to negative 3 divided by 0.5 times 100, of course. 6%, 0.6% lang. Okay, so ganun lang mag-answer ng problem that requires equilibrium calculations. Ito naman, siguro this will be the last problem na. Yeah. So the last problem for the equilibrium calculations. Calculate the Ka if the percent ionization of an acid, and the percent ionization of an acid given that 0.7 molar of HA has a pH of 4. Weird, no? Okay. So ganito muna, you show the dissociation of your acid HA. So you know the equation, so that will be H plus and A minus. Okay, so the initial concentration is 0.7 molar, but the pH is 4. So that means your equilibrium concentration has a pH of 4. And how will you know the concentration from the pH? You use anti-logarithm. Okay? So the concentration of H plus is just 10 raised to negative the pH. Remember, your pH is 4, so meaning yun ang equilibrium concentration ni solution. Okay? So that will be 10 raised to negative 4. Same as with an ion. So remember, minus x yan. Sorry. Plus x yan, di ba? Ito minus x. So meaning your HA is just 0.7 minus 10 raised to negative 4. Okay. Basically, same pa rin naman halos. Okay, same mouse. Siguro we can write approximately 0.7 pa rin. Okay, so yan, nakuha na natin yung yung equilibrium concentrations. Since we know the equilibrium concentrations, we can get the Ka value. So the Ka is the products over reactants. No? So your H plus concentration at equilibrium, A minus concentration at equilibrium, and your HA concentration at your equilibrium. Ay nanap si Ka, so plug in lang tayo. So, H plus is 10 raised to negative 4. A minus is the same. And then for the HA, the concentration at equilibrium is still 0.7 molar. Okay. This in our calculator. So it's 10 raised to negative 4 times 10 raised to negative 4. And then the concentration of acid, 0.7. So this is the Ka. Okay. So 1.43 times 10 raised to negative 8. So that's the Ka value. And now, let's determine the percent ionization. Again, for the percent ionization, you just need the concentration of your H plus divided by your original HA. Okay, so for the H plus, that's 10 raised to negative 4 molar. For the HA original, so that's 0.7 molar times 100, of course. So your percent ionization is, let's use the calculator. Okay, it's 10 raised to negative 4 divided by 0.7 times 100. Okay, so 10 raised to negative 4 divided by 0.7 times 100. The percent ionization is just that. Ang konti lang pala. 0.0142. Okay. So that's simple lang ang equilibrium problems. Okay. Again, this is just a review and this is the first part of our asynchronous discussion. If na-discuss na to sa inyo, then that's better. Okay? Pero if hindi pa na-discuss, then just watch this video. Okay? So for the second video, yun na yung full discussion ng next topic. So I separated it into two para mas mabilis yung scroll nyo. Okay? So I'll see you in the next video.